Hey guys, so in this video I want to go over Unit 5 review. This is the sheet that I passed out at the beginning of March 13th class. If you do not have it, you have access to it on our Google site. If you don't know how to get to the Google site, I've posted it multiple times in our Google Classroom. I've also have the link to it in any of my emails I've sent you or your parents. So in the first section, we are going over how to find certain values. So for the two that I'm going to do with you, you're finding x or solving for x. And in the two that I'm going to let you try yourself before I just show you the answer, you're solving for the question mark. So for number one, we have our three angles in a triangle. Well, with three angles in a triangle, you can add them all up and set them equal to 180 and then solve for your missing information. So in this case, we're going to take our first angle, which is x plus 56. We're going to add it to our second angle, which is 82. Add it to our third and last angle, which is 51, and set it equal to 180. Always equal to 180 because it's a triangle. So then we're going to combine like terms. Our like terms are 56, 82, and 51 because they do not have an x attached to it by multiplication. So we get x plus 189 equals 180. We're going to get x by itself or solve for x, so we got to move that 189 over by subtraction because it is positive. So that goes to 0, so we can mark it out. X is going to give us -9. So that would be our answer for number 2 in this little section. Alright, then I want to go to number 4. Number 4. Well, we have two of the angles inside of our triangle, but we don't have this one. So let's figure out this one. If we add this angle, which is x times, or 16 times x, plus the angle we don't know inside of the triangle, how many degrees does this have to equal? Well, it creates a straight line. So a straight line going from one side and stopping at that line again gives us 180. Well, to find this missing part right here, we're going to subtract what we already have. And that equals the missing part, that blacked out part that I just created. So I can't simplify 180 minus 16x. So this missing angle in here is simply 180 minus 16x. So then we're going to do just like we did with number 2. We have our three angles on the inside. We're going to add all of them up. So 180 minus 16x plus our second angle, which is 7x plus 14, plus our third angle, which is 58, and set it equal to 180. Then we're going to combine any like terms we have. So first one I see is negative 16x and 7x. They both have x's. Both of the x's are to the first power. So they get combined to 9x. And then we have 180, 14, and 58. They combine to 252. And then the 180 is still all by itself on the right side. The goal is to get x by itself. So we're going to subtract the 252 on both sides. Left with negative 9x equals negative 72. X is still not by itself, so we're going to divide by that negative 9. x equals positive 8. So that is our answer for number 4 in the first section. If you will, pause your video and attempt number 1 and number 3. For number 1, you should have followed these steps and gotten 70 for your missing angle. For 3, you should have gotten 33 as your missing angle. Alright, let's move on. So in the next section, you are finding the midpoint of each line segment. So in the first one, or the first two, you are given ordered pairs already. So you're going to plug that into the formula that we went over that last week that we were at school. So you can either use the formula, or you can say, I want the average of the two x values. So you would add the first x value and the second x value together and then divide by 2 because there's two x values, and that would give you the average. Or you can use the formula, which looks like this: x1 plus x2 divided by 2. And then you would have your y1 plus your y2 all over 2, and that would give you your y value for your midpoint. So in this case, we have negative 9 plus 5 divided by 2, and we have 9 plus 5 divided by 2. Then simplified, we have negative 4 over 2 and 14 over 2. And then lastly, simplified a little bit further, you have negative 2, 7. So that would be our midpoint. For the next one, we are given a graph. We have to look at this graph and determine what our points are, what our ordered pairs are. So for this first one, we have negative 1, 5. So we can have x1, y1, and our second order pair is found at 5, 1 with our x2 and our y2. So we can substitute that into our formula. We'll have negative 1 plus 5 over 2. And then we have 5 plus 1 all over 2. And then we simplify, keeping them separate. That comma is going to keep them separate. We are not adding or subtracting or multiplying or dividing these two fractions. So simplify the x values, we get 4 over 2. Simplifying the y values, we get 6 over 2. And then we can simplify one last time to get 2 over 3. Or 2 and 3, my bad. 2 and 3. So that would be where our midpoint is located at. So if you will, pause the video and try the other two midpoint problems on this sheet. So for number 2 and number 4, for number 2, you should have gotten the midpoint of negative 1/2, negative 3. For number 4, you should have gotten the midpoint of either negative 4, 5 over 2, or negative 4, 2.5. Alright, going on to the next page. So in the next section, we're doing the distance formula. So the distance formula is square root 2 parentheses addition in the middle, subtraction in the parentheses, and both of them squared. Now, in the first one, some people teach it in a different order, and it's okay as long as you keep the same order of things. So if you choose to do x here, and let's say you wanted to start with x to the first, that means the y's are going to be in the second parentheses, and that first y that we use has to be also the first y. So these would have to match. And then lastly, you would do your second x and your second y. Another way to use it is if you did your two parentheses, both of them squared, addition in the middle, subtraction in the parentheses, and you wanted to do y's first, you could do this. You wanted to start with, let's say, the second y. That is fine as long as you come into the second parentheses and you start with your second x. So y to the first, and then this would be x to the first. You get the same answer as long as you are subtracting from the first one in both parentheses or the second one in both parentheses. So let's look at the first problem. In this case, we have x1, y1, x2, y2. So we're going to have a big square root. You're going to have your two parentheses. Both of them are squared. Addition in the middle, subtraction on the inside. So I'm going to start with my x1. So I'm going to have 2, subtract my x2, which is 6. Then I'm going to do my y1, subtract my y2, which is 3. My next step, I'm going to keep the big square root. I'm also going to keep the parentheses that are squared and addition on the inside. But I'm going to simplify what is inside of the parentheses. So 6 minus 2 gives me negative 4. 6 minus 3 gives me 3. Then I'm going to keep going. I'm going to keep simplifying. I'm going to keep the square root. I'm going to keep the addition in the inside. But now I'm going to simplify negative 4 squared, which gives me 16. And then the 3 squared gives me 9. So I'm going to simplify again. Let's do, I think black shows up. So I'm going to keep the square root one more time, but I'm going to simplify the 16 plus 9, which gives me 25. And hopefully we know that the square root of 25 is plus or minus 5. And that would be our distance. So mathematically, you can just put that. You can put the plus or minus 5. But do know that if it's asking for distance, can we have negative distance? Even if we went backwards, distance is not recorded negative. So if you put plus and minus because in your mind you're thinking about our radical unit, then that's okay, but technically it should always be positive when we're talking about distance. So just be aware of that. All right. Now I'm going to go on to 3, because the other ones I'm going to get you to pause the video and do yourself. So in this one, we had to look at a graph and figure out what our ordered pairs are. So we have 1 and 5. We also have 5 and negative 5. And we have x1, y1, x2, y2. So first I'm going to create my distance formula and plug in some of this information. So the square root, 2 parentheses, they're squared, addition in the middle, subtraction on the inside. I'm going to start with x1, so 1, subtract x2, which is 5. Then I have y1, subtract y2, which is -5. Do you realize I had to put subtract -5 because the y2 was negative? Can't just ignore the negative when it's in the ordered pair. So I'm going to simplify this. I still have the square root. I still have the parentheses squared and the addition in the middle. But now I'm going to simplify inside of the parentheses. So I get -4, and I get 10. Again, going to keep the square root, going to keep the addition, but now I'm going to simplify the squares. So I get 16 and 100. Going to keep the square one last time. And I'm going to simplify the addition. So I get 116. So I have the square root of 116. I'm going to simplify that. So what times what gives me 116? 4 and 29. 29 is prime, but 4 is not, so I can keep going. 2 and 2. 2 times 2 gives me 4. So underneath the radical, I have 2 times 2 times 29. 2 2's get married, move out of the house, become 1 2. So my distance is going to be positive 2 times square root of 29 because the 29 was left underneath the radical by itself. So that would be my answer for number 3. If you will, pause the video and attempt number 2 and number 4 in the third section. So for number 2, you should have followed these steps and gotten the distance of 2 times the square root of 5. For number 4, you should have gotten the distance of the square root of 53. Zoom in just a little bit, just making sure you can see it. Alright, moving on to section 4. Section 4, we quickly touched on either Thursday or Friday before we went on quarantine. We are talking about a triangle where a line is created inside of a big triangle from connecting it to midpoints. So that is what the tick marks are referring to. The fact that T is a midpoint of line LM. Because this side of the point T is congruent or the same as this side of that point T. That's how I know it's a midpoint. Same thing with the other segment or the other side of the triangle. In between LK, the midpoint is U, and I know that because this side of the point U is congruent to the other side of point U. So this segment here is creating this relationship where we can find this distance if we know the longer distance or the longer side. So how I kind of worded this in class is that our big or outside line, in this case line MK, and our little or inside line is TU, then either line MK is half the distance of TU, or MK is the same as 2 times TU. So you can use either method. I like to take the information that is given and try to determine from that. So in this case, we know our biggest length, so we want to find TU. So I'm actually going to use this one where we're dividing our biggest, or our outside line, by 2 to find our smallest one. So we're going to do 10 divided by 2 gives us 5. So that is going to be our measurement for TU. So let's do another one. For the last one, our big line is TR. Our little is LK. So in this case, you can take your smallest line, or your inside line, multiply it by 2, and you will get your big line. So let's do that. So 2 times our small line, which is, or our inside line, which is 2x plus 28. And we're going to get the same distance as our big line, so 2x plus 32. So we're going to have 4x plus 58 equals 2x plus 32. Solving for x, so we need our x's on the same side. If you choose to do it in a different order, that's fine. I'm choosing to move the smallest x to the other side by subtraction. And then I'm going to move the 58 over by subtraction. I get 2x equals negative 26. Divide by 2 on both sides. X equals negative 13. So that is how you do section 4. If you will, pause the video and attempt number 2 and number 3. For number 2, you should have gotten the answer 12. For number 3, you should have gotten the answer 8. Okay. So let's move on. So in section 5. In section 5, we are told to prove that these triangles are congruent. So the key thing when proving congruency is to use the information that is given. So in words, nothing is given. But if you look at our figure, things are given. We are given that line DB and line CB are congruent, and we know that by our little tick marks. So this information is given, so we're going to write this down. So statement line DB is congruent to line BC, and it is given. Now, other information that is given is that if you look at these 2 little arrows, that means that they are parallel. So how we represent this in our statement or in our proof is that we do line DA parallel, and you can write it out if you really want to, but those two lines means parallel to EC. And this information is also given. Now, we have to go through this information and figure out what else do we need to find, or what else do we need to prove, so that we can say that these two triangles are congruent by either side, 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 angle, side, so on and so forth. So, if we have two parallel lines, and here are our parallel lines, and I'm going to erase everything else so we can just focus on parallel lines. We got parallel lines here. And we have a line that goes through our two parallel lines. Then what kind of angles are right here and right here? If you need to adjust how you're looking at it, aka turn it 90 degrees, your screen, it may be easier to see, but what kind of angles are these? Hopefully you see that they're both on the inside of your parallel lines, and they're on alternate sides of your transversal that is going through those parallel lines. So we're going to identify the fact that we have angle ADB and angle ECB, and we know that they are congruent by alternate interior angles. Now, is there another set of angles that we can identify? Yes. So we can identify the fact that these two angles are vertical. If they are vertical angles, are they congruent or supplementary? Congruent. So we're going to identify those as congruent angles. Angle DBA is congruent to angle CBE due to vertical angles. So now that we have identified the two blue angles being congruent due to vertical angles, angle D and angle C being congruent due to alternate interior angles, the two triangles we are working with, if you separate them out, we've got this triangle as well. We're told that this side and this side is congruent. We've got this angle and this angle congruent, and we've got this angle and this angle congruent. So we have angle, side, angle, angle, side, angle. So we have proved their congruency, and we're going to say triangle DBA is congruent to triangle CBE due to angle, side, angle. And that is how you're going to complete these proofs. So what if you're told a little bit more information than just from the figure? So in number 2, in this part 5, you're told that point C is midpoints of line AE and DB. So you're actually going to identify that, oh, C is point AE, and that information is given. Well, if point C is the midpoint of AE, what does that mean about the two sides or two segments that are created on both sides of the point C? Are they the same? Are they different? What can you say about them? Same thing with point C on line D and B. What can you say about line B and line D? So pause the video and attempt the reasons for the second proof. So for this one, you should have gotten that you can prove these two triangles congruent by side angle side. And the reason why is because those are two sets of lines that I told you before you paused the video. They are congruent to each other. The greens are congruent to each other and the reds are congruent to each other. And then lastly, you had those vertical angles. So if you wanted to separate them out, you should have ended up with two triangles that kind of look like this, where you had angle, angle, and then side, 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 side. So it would have been side, angle, side, side, angle, side. So that is how you're proving number 2's congruency. All right, third proof, if you will, pause the video and see if you can figure this one out. So for this one, I have seen it done multiple ways. The easiest way, or the simplest one I have found, is if you look at the information that is given, you're told that side AB and CD are congruent. You're told that AD and BC are congruent. And this line, BD, is congruent to itself. So line BD is congruent to line DB by reflexive property, because it's the same thing. And then you can prove it by side, side, side for its congruency. Do you know other ways that you may attempt to prove its congruency in this? There is no lines that are parallel. They may look parallel, but there is nothing telling you that they for sure are parallel. So you cannot assume that they are parallel. So as always, if you have any questions, please do not hesitate to ask either through email, Remind Message, or Google Classroom.